Is U-Space the answer to cost-efficient and safe drone flying beyond visual line of sight in the countryside, or are there better alternatives? This is the topic of today's video. I will first have a look at the situation in Sweden, and in the end of the video I will have a brief look at how things work in Norway, USA and China. I hope you find the video useful, and if so, please give a thumbs up and subscribe. It helps a lot for me to be able to keep doing these videos. I'm Johan Erlandsson and this is Future Country. In the previous video about U-Space, I explored the possibilities and possible challenges with using U-Space to enable safe and cost-effective drone operations beyond visual line of sight in the countryside. I was fairly optimistic about using U-Space in the video, but what I have learned after that is taking quite a lot of that optimism away. If you saw the video, I highlighted a wording in the regulations that said "where relevant" when it came to things like airspace surveillance, which I took as a sign that maybe the requirement for air surveillance isn't that high in a U-Space after all, if there is little manned traffic in it. This wording is, however, found in the preamble to the regulations and should not be contributed with too much weight, I have later understood. This is later in the document the hard regulations are really found. Sorry for not being an expert in interpreting these regulatory documents, and thank you to those that know better and have highlighted this for me. So we seem to be stuck with a known challenge of using U-Space in areas with little air traffic, the costly technical requirements to monitor manned air traffic. You need to be able to detect any manned aircraft in the U-Space using not one but 4 different technologies. These are certified ADS-B out on 1090 MHz, which is the most widespread and standardized method. Certified ADS-B out on 978 MHz, which is primarily used in the USA and not practically available in Europe. ADSL4 SRD 860, which is a newer technology similar to FLARM, using the 860 MHz frequency band. FLARM has been used for a long time, for example in gliders. And the 4th technology you shall use is mobile telecommunications network, where airspace users are using mobile phones or dedicated devices to transmit information via cellular networks. So if you want to set up a U-Space in a big rural area, the USSB must be able to receive all of the above radio signals in the entire U-Space all the way to the ground. If the area is not only big but also hilly, this means that there is probably a technical challenge that will require substantial infrastructure investments. If I get it correctly, maybe you will not have to receive the US version of the ADS-B standard in Europe, but the remaining 3 are challenging enough. This is why several actors now argue that we need alternatives to U-Space in the countryside. Some because they believe the cost of U-Space will be too high, as I just explained. Others because it's simply overkill with a UTM system with flight authorization, if there is not really much traffic to manage. Jörg Dittrich, an expert in drone regulations and one of the minds behind the SORA framework, makes this analogy. If you have a road crossing with a lot of traffic, traffic lights are used to avoid collisions. If there is less traffic, there are other ways to mitigate risk, like a give way sign or making sure visibility is good in the crossing. Similarly, if you have an airspace with a lot of drones in it, a UTM system with flight authorization is perhaps needed to make sure that drones don't collide. But if there are few drones, it might be enough that you make yourself visible. Flight authorization, as required in a U-Space, might not at all be necessary. You don't need authorization every time you drive a car, right? Neither manually or autonomously. You just need to follow the traffic rules. A suggestion I've heard several times to unlock the skies for drones flying beyond visual line of sight faster in the countryside is to set up a nationwide lower airspace with a set of rules that make it safe enough for BVLOS operations. I have heard many different names for this, like Airspace Class U, U-Space Light, and my favorite, Roger Space. after a well-known Swedish government official. Declaring your intentions and being inconspicuous are key in these suggestions. If we can just see each other, we can also avoid each other. This can be seen as a complement to U-space, where U-space would then only be used where it is really needed in very congested airspace. I have even heard it being mentioned as an alternative to U-space altogether, that the whole idea of a market-driven approach to where there will be U-spaces was not that great to start with, resulting in few and scattered U-spaces and a big uncertainty on how to act where there is not a U-space. In Sweden, the most elaborated suggestion in this direction, at least that has been made public, is a suggestion from the Swedish Confederation of Transport Enterprises. Their solution is 1. To make it mandatory that all operators of unmanned aircraft declare their flight prior to takeoff, and 2. To make it possible for all users to declare intentions and to make themselves inconspicuous with a low-cost solution, for example by using mobile phones. This would help, for example, paragliders to avoid being hit by drones, as then they are inconspicuous. I think this suggestion makes a lot of sense, but I think inconspicuity in the end will have to be mandatory and for all users of the airspace up to a certain height above ground level. For example, 120 meters or 400 feet, not only the unmanned. If you set up BVLOS drone operations, I don't think you want to risk hitting paragliders or hot air balloons. It will not be good for neither business nor the pilots of these aircraft. If declaring your intentions would be mandatory for all UAS operators, and it would also be mandatory for manned aircraft to check what is declared if they fly into drone airspace, and everyone in the airspace is also inconspicuous, it would for sure be a lot easier for the national aviation authorities to give BVLOS permits. If this is also combined with SORA 3.0, which is said to have better support for airspace with little traffic in it, the permit process will perhaps be even easier. SORA is a risk assessment methodology that I have explained in a previous video. See a link in the description. My guesstimate now is that 2027 is the year when everything will come together in Sweden and it will become a lot easier to get the BVLOS permit in areas with little air traffic without the need to set up D areas. Sweden's national UTM system should then be in place so operators can declare intentions. The National Aviation Authority has had time to set new rules. There has been enough time to inform all airspace users that they should make themselves inconspicuous if they plan to fly where drones fly. And finally, hopefully SORA 3.0 is also in place by then. U-space will only be used in really congested airspace. Let's also take a brief look at how things work outside of Sweden in some select countries: Norway, USA and China. In Norway, the solution so far has been to use NOTAM when performing BVLOS operations, which has simplified things enormously compared to Sweden's approach with setting up the areas to keep things safe in the early days of BVLOS drone operations. This is because Norway interpret what you need to do to prove how much manned traffic there is in an area differently than in Sweden. I think NOTAMs work okay when the number of aircraft is low and limited to one UAS operator in an area, but might not be detailed enough to achieve separation in the long run when several UAS operators are sharing the airspace. Norway has, however, via Avinor, their National Aviation Authority, just invested in a national UTM system, which will roll out later this year, 2025. The supplier of the UTM system, Thales, say, together with Avinor, we embrace the development of BVLOS services in non-segregated airspaces, enabling technologies that make it simple and economical to perform safe, repeatable and scalable commercial UAS operations. And This system will efficiently manage air traffic in the vicinity of airports and metropolitan, suburban, and regional areas, offering capabilities such as compliance monitoring, authorization management, real-time decision-making, continuous airspace surveillance, automated conflict resolution, and rapid response to dynamic conditions. In Norway, the Ninox drone app has been used for flight authorization in controlled airspace. With a new UTM system from Thales, a new app will replace the Ninox app. This all sounds very good, I think, and it will be interesting to follow how it works. Avinur said, after I asked them on LinkedIn, that with time, all airspace users, both manned and unmanned, will have to make themselves more visible, also outside controlled airspace. And the new UTM system will support that. My bet is that it will be Norway that will lead the way in Europe. As they are not a EU member, they do a bit more like they please, and will maybe not get stuck to the U-space idea as much as other EU members. In USA, we have what I think is the global leader in drone deliveries, Wing. How are they allowed to do BVLOS operations? Well, in USA there are so far 2 regulations that control drone flying, Part 107 and Part 135. Part 107 is similar to the EASA open category, and Part 135 is the regular airline regulation. The only way to deliver parcels today is via Part 135, and Wing got certified for this already in 2019. This is, however, an expensive way to go, and only the biggest drone operators are certified via Part 135. Everybody is now waiting for the new regulation, Part 108, which will be designed for BVLOS drone operations, but will be a lot simpler than Part 135. Even if Wing got the certification already in 2019, it was not until July 2024 that Wing were allowed BVLOS flight without visual observers. By implementing a UTM system and a detect and avoid system, they got an exemption from the FAA and no longer needed visual observers. The exemption is so far limited to the Dallas area. In China, a well-developed regulatory framework for BVLOS operations seems to already be in place, like in the US, requiring a detect and avoid system. China's leading home delivery drone operator, Meituan, has just received a nationwide permit for BVLOS flying, also over areas with high population density, as their drones are equipped with a parachute. So all in all, it looks like what we are starting to get used to by now when it comes to technical development. China is leading the way, the EU is lagging behind, and the US and non-EU European countries are somewhere in between. An interesting difference is that I hear more about detect and avoid systems in the American and Chinese regulations compared to the EASA regulations. Detect and avoid. It might be a topic for another video. Thanks for watching and see you in the next one.